Hi guys, and welcome back to 5 minutes of channel. Today I want to talk about an interesting encryption function introduced with JES 2.4, the JES2 Spool Encryption. In 5 minutes, of course. With JES 2.4 and Z14 and 15 machine, an installation can increase the security regarding JES2 spool, providing a simple and transparent approach to enable encryption and compression of JES2 managed data on spool. So thanks to the soft interface and RACF controls, you can identify spool dataset to be encrypted. Spool encryption does not replace any existing security feature that are provided by JES2. It provides just an additional layer of protection for spool. The key label and encryption key are created when the spool dataset is being allocated, and then they are being stored in the CKDS repository. Application does not need to be modified or recompiled to take advantage of the spool encryption because the data is encrypted by JES2 before being stored in the spool and is decrypted before presented to JES2 application interfaces. JES2 spool encryption can encrypt two types of dataset, sysin and sysout dataset. There are some requirements that must be satisfied for spool encryption, such as hardware requirements, software requirements, and maintenance requirements, as described in this slide. Before starting with spool encryption, you must consider that all systems with members participating in JES2 mass configuration must satisfy the hardware and software requirements. In addition, all key labels and encryption keys that are associated with the encrypted dataset must be defined identically on all systems. Regarding NJA nodes and RJA devices that might not support spool encryption, encrypted datasets are decrypted before sending jobs and output across NJA and RJA lines. If the target NJA node is enabled for spool encryption, the dataset can be re-encrypted when they are received. The encryption process is controlled by the security configuration of the receiving NJA node, which might be different from the originating NJA node. Then you can consider other security facilities, such as the SSL protocol that can provide security for data that is in transit between nodes in the network. When a spool dataset is encrypted, it can only be accessed with the key that was used to encrypt the dataset. If an encryption key is lost or misconfigured, any access to dataset in the spool fails. Because of the nature of the application data stored in the spool, key management practices such as key rotation are not supported for spool encryption. There are some restrictions for spool encryption, such as syslog dataset are not encrypted. Some system datasets are only encrypted if they are sysout datasets. Encryption keys must be no lower than IIS 256. For example, decimal keys are not allowed. There are no restrictions on the record format and the record length for encrypted spool dataset. With spool encryption, you can protect data that reside on spool from being viewed by unauthorized users. Authorization is based on access to key label that identifies an encryption key that is used by the access method to encrypt and decrypt the data. To do this, you have to define the JES encrypt owner and JES encrypt submitter profiles in the RACF facility class with an universal access of none. JES2 spool encryption depends on ICSF services. Then it is required that the ICSF address space, started task, runs under control of the master subsystem. Then specify sub-equal master to allow ICSF to start before JES2. For the same reason, during system shutdown, ICSF must be stopped after terminating the JES2 address space. What are the steps for spool encryption? First of all, you need to create key labels and encryption keys. that must be assigned to the spool dataset. They must exist in the CKDS repository by the time the data is allocated. Then set up RACF class CSF keys to control access to cryptographic keys that are identified by key label. If the user attempts to access an encrypted spool dataset and does not have sufficient access to the CSF keys profile, allocation of the dataset fails. Then set up the RACF class CSF serve to control the access to cryptographic services of ICSF. Then set up JES job class to be used automatically to assign a key label to spool dataset that meet certain criteria. And you can see here the format for profiles names in this class. Then define a facility class to control the ability to provide a key label on a DD statement by using a DSKeyLabel keyword. This keyword overrides a key label that is assigned to a dataset by a JESJob profile, but only if the user has read or higher access to the relevant facility class profile. And finally, you can activate spool encryption using the JES2 operator command. In conclusion, applications that use standards interface to access the spool do not require changes to access encrypted spool datasets. And the user data that is transferred between the application and the access method is in the unencrypted form. Data is encrypted as it is written to spool and is decrypted as it is read from spool. If the system supports compression, data is compressed before it is encrypted and written to spool. When reading from spool, data is decompressed after it is decrypted. Software decompression is used only if the system does not support hardware decompression. And finally, remember, for encrypted spool datasets that are to be processed by NJA and offload devices, ensure that the JES2 and its related address spaces have access to the key labels that are used for encryption. And thank you for your attention, and if you want to know more on mainframe security, follow me in my next video. Bye bye from Luigi.